Good morning, everyone. Today you're going to be working on home lesson 6. I am going to go through handout page 2-1, which is your lesson. Then you will be handing in the second page, handout 2-2. You're going to complete that, take photos, and submit it. Then I will do some examples where I'm going to ask you to write them down on a sheet of paper, and you will be handing in do a tank page 2-1, and it's just the left-hand side. All right, so for home lesson 6, let's go through a couple application questions. The first one is we have the height of a fly ball is determined by the following equation, where h is the height of the fly ball in meters and t is time in seconds. So you've got a chart to fill out here. The time column has already been filled out for you, so we're checking the height of the ball at different times. So at time 0, all we're doing is taking this equation here, and wherever there's t, we're replacing it with the t in the correct row. So time 0, I've taken 0 and replaced the t with that, so 36 times 0 is 0, minus 5 times 0 squared. So you're going to end up with 0 for the first one. If you plug in 1, it will be 36 times 1, subtract 5, multiplied by 1 squared. Make sure that you square the 1 first, and then multiply by the negative 5. In this case, it doesn't make much of a difference because squaring 1 is still going to be 1. But when you get to the next line, make sure that you square the 2 first before you multiply by the 5, right? If you do 5 by 2 and then square, that will be incorrect. BEDMAS says to do the exponent first. So I went ahead and I did the rest of them for you, so make sure you have those on your sheet. And let's graph this information now. So I've created a graph. When you're creating your graph, make sure that you've got your axes labeled. So I've got time in seconds along the bottom. I went from 0 to 8 because we need to go from 0 to 7 at least. And then along the y-axis, I have my height in meters, so don't forget your units there. I have my title. And for the y-axis, I decided to go up by 7s, okay? And if you just, the way I decided was that my lowest value is 0, and then I had to go all the way up to at least 64. So I looked at how many squares I had, and then divided 64 by that number of squares, to get an approximate value for each of the squares. So I'm going to go up by 7 so that it all fits nicely. And then I just plotted my points. So you can see that it makes a nice shape like this. This is called a quadratic, right? It's going up and then it's coming back down. And that's what this unit is about, right? This unit is about graphing quadratics, our second unit. All right, let's answer some of these questions that are based on our graph. Determine the maximum height reached by the ball. So how high does the ball go? What is the maximum height here? It's a little bit hard to see on your graph, but if we go over to our chart, we can see the highest y value is 64. So it's going to be 64 meters. Determine the time it took to reach that maximum height. So how long did it take to get to that 64 meters? And that was 4 seconds. How long was the ball in the air? So it started on the ground at time 0, it went up into the air, and then it came back down. Now at this point it's not quite on the ground, but we know it's going to continue, so it's going to be something past the 7 seconds. So I just said a bit more than 7 seconds. Okay, that's the first question. I've got one more here for you. We have an air show, and there's a path of a power diver there's a power dive by a plane that's given by the following equation. So it's one of those planes that do stunts. H is the height of the plane and in meters, and then T is in seconds. So I've got my times here, and I want to see at these different times what is the height of the plane. So I did the same thing as in question 1. I substituted these values into my equation here, okay, to figure out what my height is at each of those times. And then I plotted those points, and this is what it looked like. Don't forget your title, label your axes, include the units, and I decided to go up by 10s, okay, on the y-axis here. What is the minimum height of the plane? So it starts off at 80 meters, and then it goes down towards the ground, and at a certain point it changes direction, and then comes back up. So it's asking how low did the plane go before it changed its direction to go back up. So you can see that the lowest height would be right here at 55 meters. What is the height of the plane when it starts the power dive? So that's the initial height. So at time 0, what is the initial height? It looks like it's 80 meters off the ground. Okay, so those are your two examples. You're going to be completing the next page, so H2-2, and there's a couple examples here. One's a golf example, and the second one is for a output for a power of a electric generator. Be careful with the first one. It's negative t squared plus 6t when you're substituting your values of time in. So if I plug in 2, it's negative, then the 2 gets squared plus 6 times 2. You're going to square the 2 first, which will give me positive 4, and then you tack on that negative sign in the front, right? So it's negative times 4, which is negative 4. So be careful with that, plus 12. So you should get 8 meters for 2 seconds. All right, so you're going to complete those two examples, take a photo, submit it. The second part of today's lesson, you'll have to write this down on a piece of paper. All right, so for the portion of this lesson, what you'll need to do is make sure that your equation is factored first, and then you're going to solve. Okay, so what that means is you're going to be looking for values of m that make this expression true, right? So what can I plug in for this m so that the left-hand side is going to be equal to the right-hand side, which is 0. That's what you'll be doing here. The first step is to always make sure that all of the terms are on the left-hand side of the equal sign. So if you have a term over here, like 2m for example, make sure you bring it to the other side and change the sign so that it's equal to 0. And second step is to make sure it's factored. This one happens to be factored already. Once it's factored, you're going to take each parts, okay? So negative 2m is one part, and then m minus 3 in the bracket is the second part. You're going to take each of those and make them equal to 0, and you're going to solve. So negative 2m equal to 0. To solve for m here, all we need to do is divide this side by negative 2, right, so that they can cancel, and then do the same thing on the other side. Okay, so you're still going to end up with m is equal to 0. So that's one solution. The second solution, to solve for m, you want to take this negative 3 and move it to the right-hand side, and it becomes positive 3, okay? Or you can look at it as adding 3 to both sides. So you'll end up with m equals 3. So there's two solutions to this, and it would be 0 and 3. So I could take either of these values, plug them in, and you will end up with 0 equals 0. So if I plug in 0 for m, you will have 2 times 0 is 0, and then 0 minus 3 is negative 3, and then 0 times negative 3 is still equal to 0. So that works. If you try plugging in the 3, in the front here you'll have 2 times 3, which is, or negative 2 times 3 is negative 6, and inside the bracket you'll have 3 minus 3, which is 0. So you've got negative 6 times 0, which is still equal to 0. So both of these values make this expression true. And that's kind of the goal for all of these questions. I've got a few more to show you. I'm going to go through numbers 2, 3, 4, and 5, and then 6, 7, and 8 I'll just kind of leave. You can just pause the screen to look at more examples yourself, but I'm just going to explain numbers 2, 3, 4, and 5. So for number 2, this is already factored, so just take each of the parts in the brackets, make them equal to 0. So we have 2x plus 7 is equal to 0. And then just think about your rules for solving. You want to bring the 7 over to the right-hand side first, so that it becomes negative 7, okay, or subtract 7 from both sides, and then divide both sides by 2 to solve for x. Okay, so one solution is negative 7 over 2. The second solution is, we've got x plus 2 equals 0, bring the 2 to the other side, so it becomes negative 2. So there is our second solution. Question 3, this one is not factored, okay? So this is trinomial factoring. You're thinking of two numbers that multiply to 2 and add to 3, and those values are going to be 1 and 2, right? 1 times 2 is 2, 1 plus 2 is 3. So I've factored this as x plus 2 and then x plus 1, Now I'm taking each of those brackets and I'm solving for x. So x plus 2 is equal to 0, which means x is equal to negative 2. X plus 1 is equal to 0. Bring the 1 to the other side, it becomes negative. So we have x equals negative 1. So there's our two solutions. Question number 4. Okay, so here we've got 3x squared minus 81x. So I divided both of those sides, or both of those terms, by negative 3x. I common factor negative 3x out. So that's what you can see here. So 3x squared divided by 3x is x, and 81x divided by 3x is 27, okay? And the 3x in the front is what I factored out initially. Okay, so this is going to be one solution, so 3x is equal to 0, which means x is equal to 0. And for the second solution, x minus 27 is equal to 0. Bring the negative 27 to the other side, make it positive. So there's our second solution. Okay, I'll do one more example. So this example here, notice that not all terms are on the same side, so we need to bring this negative x squared over to the left-hand side first, and it becomes positive. Now we have a nice trinomial. So you're looking for two numbers that multiply to 24 and add to 11, which are 3 and 8. Okay, so it's factored, and each of these bracket parts are going to give us a solution. So the left one is going to give us x equals negative 3, and this one's going to give us x equals negative 8. Okay? And you could test if these are true. You could plug in the negative 3 to the original equation. So 11 times negative 11 times negative 3 is negative 33 plus 24. Work out that side and see if that is equal to negative 3 squared times a negative 1 in the front there. And you'll see that they're equal to each other. Okay, so 6, 7, and 8 I'm not going to go through. You can just pause the screen if you like to write these down and look at them in more detail. This one here, bring the 9 to the other side, and this is a difference of squares question. You can see this question here, you have the common factor first before you factor the trinomial. And then the last one, this looks like a decomposition question, so you'll need to multiply the 5 times negative 3 first, so looking for two numbers that multiply to negative 15 and add to 14, okay, and use decomposition that way. There we go. So those are all of your examples, so you should have some of those in your notes to refer to when you are working on the second part of the homework, which is going to be do a tank 2-1, and you're doing the left-hand side. Okay, you're going to be solving numbers 1 through 19, okay, just every second question. You don't have to do the even numbers on the right-hand side. So try those. I think there's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so you're doing 10 questions. So hand that in. And then also the 2 word problems on the handout 2-2. All right, so that is your work for today. I will be in study hall again today at 2 o'clock if you want to pop in and ask for a little bit of help. All right, good luck. Have a great day.